In this video we're going to learn about rearranging formulae and equations, and we're going to look at substituting numbers into equations and formulae too. Formulae is the plural of formula, so you could say formulas, but the correct word is formulae. You may want to watch the video at a faster speed on YouTube. It'll be quite a long one, and you can watch it at say 1.5 or 1.75 times speed on YouTube, and then just rewind it when you need to. The first thing I'll look at is something I call change the side, change the sign, and I'll just put some dummy numbers in here, 10 equals 6 plus 4, to explain how it works. So when you're asked to rearrange formulas or equations, you may ask to make a certain variable, one of the letters in the equation, you may be asked to get that on its own. So say I wanted to get the 4 on its own here. I wanted to rearrange this as an equation because it's got an equals sign. If I wanted to rearrange it so that the 4 was on its own, I'd have to move the 6 to the other side. So when I move the 6 over here to the other side, at the moment it's plus 6 because there's nothing in front of it. We assume it's positive. When I move it over, it becomes negative because we change the sign, having changed which side of the equal sign it's on. So this becomes 10 and minus 6 equals, and all that's left is 4. And that is correct. So we had 10 equals 6 plus 4, and then we moved the 6 to the other side. It became minus 6. 10 minus 6 is 4. If I started again, if I wanted to get the 6 on its own, I'd have to move the 4 to the other side. So if I was moving the 4, I would be changing the side. So I'd need to change its sign to negative from positive. And what we'd end up with is 10 minus 4 is 6. And that's correct. So a lot of the time, when you've got numbers added or subtracted in equations, this is what you'll do. You can move them numbers to the other side, but you have to change their sign. And one last example on these numbers. If I wanted to move the 10 to the other side, it'd have to become minus 10. So what would happen here, if I move the 10 to the other side, we've got nothing here on the left-hand side. This is the left-hand side of the equation, and anything to the right of the equal sign is the right-hand side. So if I was moving the 10 from the left-hand side to the right-hand side, there'd be nothing on the left-hand side. We would have 0 equals 6 plus 4, and that would become minus 10. And of course this is right. 0 is 10, take away 10, so that works. So just be aware of that change the side, change the sign, which applies to when we've got numbers added or subtracted. The next rule that we'll be using a lot when we rearrange equations and formulas, or formulae, is what I call swap and drop. So when we swap and drop, what we're doing, we're dividing both sides of the equation by a certain number or variable. These are like variables or terms in an equation. There's one you'll be using later on, which is work done. The amount of work done by a system is the force applied times the distance that an object has moved. So when you push on an object with a force, it moves a distance, and force times distance gives us the work done. So the formula for this, it's still an equation because it has an equals sign, but it's a formula because it's like a well-known equation, if you like, that we use. So W equals F times D, and in algebra we would write that as W equals FD. If we wanted to make F the subject, what that means is get F on its own, either on the left-hand side or the right-hand side. If we want to make F the subject, how do we work that out? How do we write a rearranged formula for what the force is compared to work and distance? Well, this is where we do swap and drop. If you want F on its own, we need to move d. So what we do, we take d, we swap it to the other side, and we drop it underneath the w. And that's the same as dividing both sides of the equation by d. So what we end up with is that f here is equal to w over d, or w divided by d. So that's the swap and drop. We could do another example with these variables. If we have work is force times distance. If we want to make distance the subject of the equation or formula, then we would have something equals d. So d is on its own, so it's the subject. So what we need to do in that case is take the force, swap it to the other side, and drop it down as a denominator. So what we end up with is w over f is equal to d. So that's the swap and drop, which is a simple way of saying divide both sides by a number or by a variable. And we can prove that this works by putting some dummy numbers in. So if I had, say, 20 equals 10 times 2, we know that's true. But if we want to get the 2 on its own, if we wanted to have the equation saying something equals 2 or 2 equals something, as in having the 2 on its own, then we need to move the 10 from the right hand side to the left hand side. So you swap it and you drop it underneath. So 2 is going to be equal to 20 divided by 10, and that's correct, of course. If we have an equation 30 equals 10 times 3, which is correct, if we want to make 10 the subject, as in have the 10 on its own, even though it's on the right hand side, it's still a subject of the equation because it's on its own. But to get the 10 on its own, we need to take the 3 and swap and drop it under the 30. So 30 over 3, or 30 divided by 3 is 10, and that is correct. So this is a useful tool to have when you're rearranging equations and formulae, swap and drop, which is the same as dividing both sides by a number. When we move the 3 across and down, what we were really going to do, we're dividing both sides by 3. So we would end up with 30 over 3 and 10 times 3 over 3. Divide both sides by this 3. But 3 over 3 is 1, so it disappears because 30 over 3 is 10 times 1. It's the same as saying 30 over 3 is 10. So you'll get good at these with practice, but there's another thing we need to look at first, another way of rearranging. The next trick we'll look at is slide and rise, which is when we're multiplying both sides of an equation or a formula by a number or by one of the variables. Here we have a voltage divided by resistance gives us current. V over R equals I, which is from Ohm's law. You'll be using that throughout this unit 661. So imagine we want to make V the subject. So we want to get V equal to something, or we want to have something equals V. That means V is the subject because V's on its own. He's Billy no mates, he's on his own, and that means it's the subject of the equation or formula. So in order to get V on its own, on the left hand side, say, we take R and we slide and we rise. So R at the moment is on the left and on the denominator, so we slide it to the right and rise it up as a numerator on the normal line next to the I. So this formula, when we rearrange it, becomes V equals I. The I stays put, but now it's got an R next to it. So that means V equals I times R. And if we wanted V on the right hand side, then it depends which way you're given the formula, but both of these are correct. So we took the R, we slid it, and we rose it up. So slide and rise. To check that it works properly, put some dummy numbers that we know are true. 10 divided by 5 equals 2. Yeah, but if we want to get the 10 on its own, we take the 5, we slide it, we rise it. 10 equals 2 times 5. When something's next to something in algebra or formulas or equations, it means multiplied by. So 10 is 2 times 5. We could have written 33 over 11 equals 3. That's right, because 33 divided by 11 is 3. If we want to get the 33 on its own, we take the 11, slide, rise. 33 is 3 times 11. So we've just transposed a formula, which means, you know, we've rearranged it. We've made 33 the subject. In this original equation here, 3 was the subject because 3 was on its own. But in this one, 33 is the subject because 33 is on its own. So these are really useful tools where you change the side, change the sign when you've got numbers added or subtracted. And you swap and drop, or you slide and rise. And you'll be using these a lot. So let's have a go at some equations that you will have to rearrange. So here we have 3 lots of x plus 4 is equal to y. And we're going to make x the subject. So eventually x is going to be on its own. So the first thing we need to do, because we can't just move x to the other side on its own because it's stuck with the 3. It's 3 times x, so it's 3 glued next to the x. So we need to treat this term as a thing in itself that we need to keep it as it is for now because it's 3 times x. The 3 is stuck to the x. So the first thing we can do to start getting x on its own is to move the 4 from the left-hand side of the equation to the right-hand side. So we're going to change the side, change the sign for the 4. So what we end up with is 3x. The y stays there, the equal sign always stays there, but the plus 4 is moving to the right-hand side, becomes minus 4. So this is true, and this is true. 3x plus 4 equals y is true, and 3x equals y take away 4 is also true. But we still haven't got x on its own. So what we need to do is effectively divide both sides by 3. So we need to move the 3 across and down by swap and drop. So we end up with x equals, we've got y minus 4 all over 3. So we took this 3, we swap and dropped it. So we end up with x is y minus 4 all over 3. And now x is the subject because it's on its own. So we've done it. And at this point we may as well introduce substituting numbers into variables. So all that means is stick a number in where a letter is. So you may be asked additionally to substitute y as the number 16. So you plug 16 in wherever you see y, and then we can work out the actual value of x. So x is equal to y, but in this particular circumstance y is 16 because we've been told it's 16. So x is 16 minus 4 all over 3. So that means x is 16 take away 4 is 12 divided by 3. So therefore x is 4. You'll only be asked to do this when it's a substitution question. They'll tell you what numbers to plug in. but I thought I would just continue our rearranging at this point just to give you an example of substitution. So here we've got a nasty looking equation, 8x plus 4y divided by 6 equals 4, and it's asking us to make x the subject. It'll either say make x the subject, or it'll tell you which variable needs to go on its own. So you might be looking at this and you might think, how on earth am I going to get x on its own? Because there's so much other stuff. But we will get there. So the first thing to do, because we can't move the 8x over, we can't move the 4y over yet, because all of the left-hand side is divided by 6. So the first thing to do is move the 6 over, slide and rise, from the left-hand side denominator to the right-hand side numerator. So what we'll have, we'll grab this 6, we'll slide and rise, and it'll multiply next to the 4. So we have 8x plus 4y equals 4 times 6. And at this point, whenever you see numbers that are an easy win, you may as well just multiply them together. So 8x plus 4y equals 4 6s 24. So we started, but we still don't have the 8x on its own. What we can do next, because we have something added to something else, because there's a plus sign, so we can treat this as a little bubble, treat that as a little bubble, and we've got a plus in between. So we can take this little bubble on the 4y, and because it's added or subtracted to something else, we can do the change the side, change the sign. So we're going to move it to the other side and change it from plus 4y to minus 4y. So what we end up with is 8x equals 24, and we change the sign of this. It becomes minus 4y. And we're nearly there. We've nearly got the x on its own. But it's 8 lots of x, so we need to divide the left-hand side by 8 and divide the right-hand side by 8 to get x on its own. But that's like doing a swap and drop for the 8. So we take the 8, swap it and drop it. What we end up with, x equals 24 minus 4y, and the 8, remember, has moved across and down, so all of this is over 8. So now x is the subject. So we have rearranged this equation to make x the subject. We don't know what the value of x is, because we don't know what the value of y is. But if we were told the value of y, we'd be able to work it out. So if we were to substitute a number into y, then we could do that. So we may as well do that now. It's a different type of question, but it's still worth doing. If they say substitute, say y is equal to 1, then what this will become is x equals 24 minus 4 lots of 1, because it's 4y, over 8, which is equal to 24, take away 4, all over 8, which is equal to 20 divided by 8. 8 goes into 20, twice is 16, then a half of 8 makes 20, so that is 2.5. So you would use a calculator. You'd be allowed to use a calculator to do this anyway. So once we've given a number to substitute in for y, we can find out what x is here. So x is 2.5. So what I'll call example B here, we're going to make x the subject. So get x on its own, either on the right hand side or on the left hand side, but get it on its own. It's self-isolating. So There's more than one way to start them off. If we want to get the x on its own, the first thing we need to do is get the 3x or the minus 3x on its own. So in order to get this term on its own, because it's got a minus or a plus between this term and this term, we can put 5y in its own little bubble. So it's this bubble plus this bubble equals 3. And because it's plus or minus, we can use change the side, change the sign. So we can take the 5y, move it to the other side, and change its sign so it becomes minus 5y. Because if we do that, we've only got minus 3x on the left side, so we're getting a bit closer. So we're going to take 5y, move it to the right hand side, and make it minus 5y. So on the left hand side, all we'd have left is minus 3x, and that's equal to 3, that 3, minus 5y. And what we can do next is take the minus 3, swap and drop. So we'll end up with, that's to get the x on its own, because we've got minus 3 lots of x, but we only want one lot of x. So we can take the minus 3, swap and drop. So we end up with x equals 3 minus 5y all over minus 3. And it doesn't look very pretty, but we don't care, because we're only asked to rearrange to make x the subject. It said make x the subject, and x is on its own, so we've done it. We don't care how horrible it looks, because we've done what they asked us to. Next, we've got 3y plus 7x equals 6. We want to get x on its own. We want to make x the subject. So the first thing we want to do is try and get the x term. This is the x term, like 7x. We want to try and get that on its own. So we've got one term here, 3y, added to another term here, 7x, and that's equal to 6. And because we've got something plus something else, it's an addition. So we can take the 3y, move it over to the other side. And when we move it to the other side, we change the sign of it, because that will give us just the 7x on its own, which is part of the way to getting x on its own. So what we're going to do, take the 3y, change it from the left hand side over to the right hand side, and change its sign. So what we end up with on the left is 7x, then we have the equals, the 6 stays where it is, and this 3y term changes side and changes sign. So it goes from plus 3y to minus 3y. So we're getting there. Next, what we need to do is the same as dividing both sides by 7. So divide 7x by 7 and then divide 6 minus 3y by 7. But what that is, the trick that we use is swap and drop. So if you've got a number times x, you take the 7, swap the sides, drop it down. So what we're left with is x is 6 minus 3y, all of it, over 7. You can't just put the 7 underneath the 6, because we need to divide the whole of the right hand side by 7, because what we've effectively done is divide all of the left hand side by 7, and you need to treat equations equally on both sides. So we've made x the subject, and it is correct. We don't know what x is worth until we substitute a value into y, but we don't care because we haven't been asked to do that on this question. Question D, y equals 4x plus 5 over 2, and we're being asked to make x the subject on its own on one side or the other. So you're looking at this, you're thinking, right, how on earth do I get the x on its own? The x is glued to the 4, They're like Forrest Gump and Jenny. They stick together wherever possible. So we've got 4 and x are stuck together because it's 4 times x. So we can't move the 4. We can't move the 5 on its own because all of the right hand side is divided by 2. So what we'll do, we'll move the 2 over, we'll slide and rise the 2. So take the 2, slide it from the denominator, rise it up next to the y. What we end up with is 2 next to the y, which is 2 times y, which is 2y, equals whatever else was there to start with, 4x plus 5. Getting a little bit closer, we ask ourselves now, how do we get this 4x term on its own? Because he's got this little annoying friend 5 that wants to hang around with him. We want 4x on its own, but 5 is in the way. But because we have an addition, it's 4y plus 5, we can move the 5 to the other side, change the side of the 5 from the right hand side to the left hand side, and then change its sign. So change the side, change the sign. And what we end up with on the left hand side is 2y. This was a plus 5, so it becomes a minus 5 equals 4x. So we're getting a lot closer. Instead of having x on its own, which is what we want, we've got 4x on its own. So it's clear that we need to divide both sides by 4. Well, I say it's clear, that's easy for me to say, but it will become clear that what we need to do is divide both sides by 4. So because the 4 is glued to the x, we can't change the side, change the sign, because there's no plus or minus in between them, but we can swap and drop the 4. We want to get this 4, we want to get rid of it somehow, but it isn't 4 plus x or 4 minus x. It's 4x, it's 4 times x. So we can't take the 4 over and change its sign. Because it's multiplied by the x 4 times x, we need to swap and drop. You can only do change the side, change the sign when things are added or subtracted. But this isn't 4 plus x or 4 minus x. It's just 4 glued to x, which is 4 times x. So we need to take the 4, swap and drop. What we end up with is 2y minus 5 divided by 4, because we dropped the 4 down, so we need to show this division line. And all that's left on the right hand side, barely no mates, little x. And even though it's on the right hand side, it's still the subject because it's on its own. So this is correct. So we've ended up with 2y minus 5 over 4 equals x. If you want to make x on the left hand side, then okay, you do x equals 2y minus 5 over 4. Because this left hand side is equal to this right hand side, and because they're equal, you can display them on whichever side of the equal sign you want. So this is also true. And this is the standard way that we would normally do it, but this one is also correct. We'll do a few more. So we've got 7x minus 3y all over 6 equals 10. And you're thinking, right, I really don't want to do this. But we're going to make x the subject. The big clue, when a whole side of an equation is divided by something, then get rid of that something. We need to take the 6, slide and rise, multiply it by the 10. So we end up with 7x minus 3y equals 10 times 6. And at this point, we may as well clean it up. 7x minus 3y equals 60. Next, we want to figure out how do we get the 7x on its own so that later we can get the x on its own. Well, we've got 7x and we've got a minus or a plus here, So if we've got a minus or a plus in between two terms, we can use change the side, change the sign. So we're going to move the 3y. It's minus 3y, so we're going to move it to the other side, and we're going to change its sign to plus 3y. So we end up with 7x equals 60 plus 3y. Happy days. We could only move the 3y with the change the side, change the sign, because it was part of an addition or a subtraction. So we've got 7x equals 60 plus 3y, but we don't want to know what 7 lots of our answer is. We want to know what 1 lot of our answer is. We want to know what x is, not what 7x is. So we need to divide the left-hand side and divide the right-hand side by 7, which is the same as getting the 7, because it's stuck to the x. There's no plus or minus in between them, so it's going to be a swap and drop of the 7. So we end up with x equals 60 plus 3y all over 7. X is the subject, and we've done it. We don't know what x is because we don't know what y is. But if someone walked up to you in the street and said, "Oh, today y is equal to 5, then you'd say, "Oh, cheers, mate. I don't know why you're telling me that." But you would say, right, if y equals 5, if we were told that, then x is 60 plus 3 lots of 5 all over 7. And then you would just work that out and you know what x is. That's called substitution, when you stick a number in that you didn't know before to work out what x is. In this one, we've got 7t minus 8 equals 3x. That's not 70, it's 7 lots of t. 7t in algebra minus 8 equals 3x. You could be asked to make x the subject, or you might be asked to make t the subject. Well, first of all, let's make x the subject to get x on its own. Well, we've got 3x here, so because there's no plus or minus there, it's 3 stuck to x. Take the 3, swap and drop. 7t minus 8 over 3 equals x. Job done. If we were to do a slightly different question, so you've got 7t minus 8 equals 3x, but if we were asked to make t the subject, I would take 2 sugars with mine, but if we were to make t the subject, it's going to be slightly different, the answer. So what we have here is 7t, and we have a minus 8. And because there's a plus or minus in between these two terms, this is a term and this is a term, we can move the 8 over, move the minus 8 over, and it becomes plus 8. And then we've got the 7t on its own on the left-hand side, only because we've been asked on this occasion to make t the subject. So we need the equation to say t equals something or something equals t. So let's take the minus 8, change the side, change the sign. 7 times t, or 7t, equals 3x, and it goes from minus 8 to plus 8. That didn't hurt, wasn't too bad. And now, instead of knowing what t is, we know what 7 lots of t is. So we need to divide this by 7 and divide the right-hand side by 7 as well, which of course you probably remember now is we can't change the side, change the sign, because it's 7 glued to t, it's 7 times t. So take the 7, swap, drop. We end up with t equals 3x plus 8 over 7. And that's done. We've made t the subject of this horrible looking equation. If somebody said, turned it into a substitution question, if they said, I don't know, if they told you that x was equal to 10, then you go, okay, well, I'll plug 10 in where I see x. So you'd end up with t equals 3 times x would be 3 times 10 in a substitution version of this question, plus 8 from there, all over 7. And that would be 30 plus 8 is 38 over 7. That's what t would be worth if we were asked to do that on substitution. You'll certainly be told what you're expected to do in the question, whether it's a rearranging question or a substituting a number in question, or both. So next we're going to do a little bit more on substitution. That means to you and I sticking numbers in where you see letters. We're assigning values to variables to the maths people out there. So if we look at question 8 of substitution, the band The Who wrote a song about substitution, for those of you that are old enough to remember. We'll look at question A, 8x minus 3y equals t, but it's telling us that here x is equal to 1 and y is equal to 2. So whenever you see an x, you stick a 1 in. Whenever you see y, then y is worth 2. So let's plug those numbers in. 8 times 1, you can use a bracket to show times, minus 3 times 2 equals t. And it wants us to work out what t is, and it'll tell you what it wants you to do. So that is 8 times 1 is 8, minus 3 times 2 is 6. 8 minus 6 is equal to 2. So here t equals 2. Next we've got 3y plus 7x equals w, where y is 5 and x is equal to 2. And we're going to substitute 5 wherever we see y and going to stick 2 in wherever we see x. So 3 lots of y in this question is 3 lots of 5, plus 7 lots of x in this question is 7 lots of 2 equals w. We'll work out what w is. So 3 lots of 5 is 15, plus 7 2's are 14, so that is 29. So in this question, with these values for x and y, w is worth 29. Finally, 3x squared plus 2x plus t equals p. It wants us to work out what p is. So x is equal to 3 in this question and t is equal to 0. Well, let's put 3 in wherever we see x, and let's put 0 in wherever we see t. So that's 3 times x squared will be 3 squared, plus 2 lots of x is 2 lots of 3, plus t, but t is worth nothing, so put plus 0 equals p. So 3 times 3 squared, when we do a bit of work on the order of operations, you have to work out anything that's squared first, like BIDMAS or BODMAS. Have a look at that first, but you have to do squareds first. So that is 3 times 3 squared. 3 squared is 3 times 3, so that's 3 times 9, plus 2 times 3 is 6, plus 0 equals p. 3 times 9 is 27, plus 6 plus 0 is equal to p, but of course 27 plus 6 is 33, so here p is worth 33. So we've substituted some values into our variables to make to work our answer out. So that is about as hard as it'll get with substitution. So hopefully this work has been useful, a useful video to you. We did change the side, change the sign, rearranging equations and formulae where things were added or subtracted. And we also used swap and drop where we needed to divide both sides by a number. And we did slide and rise when we needed to multiply both sides by a number. So you'll need to watch this video more than once. You can look at the textbooks shared with you. You can search for other information on YouTube, and I'll give you some questions to do. And good luck.